Okay, so yeah, so today agenda will be SQS. We'll talk about the messaging integration for today, how you can do like the messaging services work in AWS and what are the different services. So for that, we'll talk about SQS. So we had in messaging like SQS, then we notify. So SNS, we already saw that how you can create and send out the emails and these things. Then we have SQS. Then we have Kinesis, where Kinesis will be the for real streaming of our data from 4 different sources. We'll discuss about all 4 sources. We'll talk about one of the lab exercise of the Kinesis. Then we'll talk about Amazon MQ, which is again one messaging service. And then we'll talk about API gateway, where we'll see that how we can create the APIs, REST API basically in Amazon, and how we can deploy that API with the help of Lambda function. Okay, so now let's start about the introduction to messaging, that what actually messaging and these things means. So like when we build different applications or numerous applications, so to get communication between each other and to get communication between the applications, what we do that we have to have some kind of a communication mechanism. Okay, so that basically it can read out the instructions and like perform those instructions, or if there should any message or something has to be read, it can be read. So here like in a demo we'll be talking about mainly the buying and a shipping service, where buying service means like if when you are doing something like when the buy order has been purchased, so let's say you are sending the message that okay, you bought this particular product, and then once the ship, then it will be like further proceeded for the shipping service. So now in shipping you will get that your order will be shipped sooner, or your order will be shipped at so and so date. Now we have in Amazon 3 types of services. The one is the SQS, another one is the SNS. Now SQS is mainly stands for simple queue service, which basically uses the queue, and it depends on the producer consumer model. We'll talk about that model. Similarly, SNS, we know that it is simple notification service, which depends on the publisher and subscriber model, that you publish a particular model and you publish a particular notification, and whoever subscribes to that notification, you will keep on getting the notification. Like you do the same kind of a mechanism in other pages. Like let's say that if you are registering for any let's say that you register for you read some blog and you register for subscribe to that blog. So subscription means whatever the new blogs or whatever the new communication would be there, that will be delivered to you. Similarly, Kinesis is for the real-time streaming basically. That also again depends on the producer and consumer model. Now we have here 2 kinds of a service communication basically. One is the synchronous and other one is asynchronous. Synchronous means like direct application to application, you are doing the communication. There is no other third party or no other mechanism is involved. Means that if something is lost, or if your message is lost, or it fails, it is not possible to retrieve it back, or like you will not able to trace it that where it went or why you didn't got it. So asynchronous or event-based communication mechanism is the preferable way, because there you have a queue kind of a system where your messages are stored in a queue and then they are processed accordingly. So that if something fails or something happens, you can actually track via the queue that what happens, or you can control the messages from the queue wherever the messages are stored. So let's talk about the SQS service. So SQS service, as I said, that it stands for a simple queue service, which basically allows which basically used to decouple your application. Means decouple the application means there are different components in the application, so it decouples your applications, the different components, so that all the components can interact in a proper way. Okay, just by the naming convention, it says that it's basically the use of the queue which is there in the service. However, if you see this particular diagram, how it works is that you have a producers which is sending the messages to the queue, and there are consumers which would be receiving the message. So this depends on the producer consumer component, where your producer component would be nothing, it will be sending the messages to the queue, and consumer component will continuously read or continuously poll for your messages from the queue. Okay, here we'll talk about like all the features which we have in a high level, and going forward we'll see in the slide how what each and every feature in a detailed way. Now, apart from that, it also helps like the consumer components. They have like the polling kind of a mechanism which is there. It says that they have a short and long polling. So the reason why I have collated all these points at a first slide itself rather than talking in a different, so that you can get a high level idea that what all things are there in these services, and these all are the keywords for your question. Because when you read the exam, so you get the long polling or short queue and long queue, these kind of terminologies in your exam. In the question you get all these kind of things. Apart from that, there is a very important feature in it. It is known as a visibility timeout. We'll see what it is, but visibility timeout is a very important feature, and most of time we get question on the visibility timeout only. And there is one more feature known as dead letter queue, which is again not too important from exam point of view, but it is important to store the failed message or the message which has not been processed. So let's see these features one by one. Before that, let's see the different type of, first let's talk about the queue and these things. So queue is what? Queue is basically, it's you can say kind of a store or a place where all the messages are stored in a sequential format or non-sequential format also. So here in SQS has two types of a queue mainly. One is standard queue and other one is FIFO, FIFO, first in first out queue. However, there is also one more queue known as a delay queue. Okay, so first we'll talk about standard queue and let's see that what it is and how it works. Standard queue means first of all that in any order the messages will be delivered. Okay, whatever, let's say you have 1 2 3 4 5 6 7 8 and again one messages, again one is there. So it can send the duplicate message. Okay, it can allow the unlimited number of the transactions or the messages per second. There will be no guarantee of the order of the message. Means you can send any number of message, but there will be no guarantee that whether the order if you send first, so first will only go, or if you send second first, so second will only go first. So in any order the message can go. And it says that one message will be delivered at a time. So one message is being delivered at a time. That is like a normal process, and obviously you would not like to get all the messages at a time. It can scale as it is fully managed service. So it is a managed service by AWS. AWS takes care of the things. So it can scale itself from one message per second to 10,000 messages per second. Means so it can scale up from it can send in 1 second up to 10,000 messages at per second. Okay. Now all the messages which are there, they are stored there for a particular period of a time. After a period of a time, the messages get expire, or you can say that they are deleted. That default retention period of a messages is 4 days, and maximum you can set it to 14 days. So from default 1 day to 14 day, any time of a day, minute, hour, like if you convert 14 days to hours, you can store it in the hours also. So any time from the 1 day to 14 day, you can put the retention period. Okay. Now it also gives you the very low latency. That is one of the feature of the standard queue. And there is one limitation that there you can send 256 KB message at a time. So you can send only the 256 KB of the message. That is the size limitation in this particular queue facility. So basically standard queue, two important points here are that there is no guarantee of order of the message in standard queue, and you can send unlimited, like you can send any number of limits of message at a time. However, in FIFO queue there is a limit for that. Now let's see how before that a delay queue. Delay queue, by the name itself, like it says that there is some delay, or there you might give some kind of a pause action in this. So delay queue, what it says, that when you send a message, sometimes you don't want any person that he should send a message, he should see the message at immediately. Okay, so normally in any kind of a queue, the default delay queue is 0 seconds, because the message will be available immediately. Whereas when you set the delay queue, at that time the message will not be available for a particular time, and that you can set up to a 15 minutes. Okay, it's, you can like see that something, let's say that if somewhere there is a feature that, okay, you want to fix, you forgot that, okay, at 12 o'clock to wish someone, and at 8 o'clock you have scheduled your email to send out that email at 12 o'clock to wish him on whatever occasion you want to do that. How those features are not with messages. So I just took an example of an email. Now, this feature, like there's a parameter known as the delay seconds parameter, which you have to set so that the default queue level, which is set to 0 seconds. So if you set that delay seconds parameter, it is basically the API parameter, API method delay seconds. So if you set that particular parameter, it will override the default queue level, the default queue level at a 0 seconds to whatever the timer, whatever the seconds you have put. So here as we see that we have the producers which are sending the messages, but our consumer will keep on polling the message, but as the delay seconds will be applied to the queue. So let's say if you have applied a delay seconds of 5 minutes, so after 5 minutes consumer will see that, okay, there is a message, and he or that consumer will can poll the message and can get the message. Okay, any questions with the standard queue and delay queue before we see that how this particular things work, and before we talk about producer consumer? Okay, so what do you do to produce the message? So to produce any message, you have to define the message body, which can be up to 256 KB only. Now to define the message body means whatever you want to write, you will write in the message body, like what in the text format, whatever you want to define, you can define it. Now once you have done that, after that you add the message attributes. Now message attributes is optional. Okay, it is again the optional field. So message attribute is an optional field. Message attribute is nothing that you just want to, like you are doing the tagging you is again the optional thing, like which you do that, okay, you give the name and a value, so key value kind of a pair, just to recognize that, okay, what this was the first message, this was the second or third, or whatever the way you want to put the conventions. Again, delay delivery you can put if you want to, so you can put the delay delivery. But once you have sent out the message, what you get, so once this message is sent out to the queue, to the SQS queue, you basically get one message identifier and one MD5 is basically the hashing algorithm, which says it stands for message digest 5. So it gives you MD5 hash ID, okay, which we use further. So message identifier and MD5 is the output for any message which you send to the queue. Okay. Now, when you consume message, so consumer will, what it will do, it will keep on polling for the new messages to see that, okay, how many messages are coming, and it can receive up to 10 messages at a time. The messages should be produced within the visibility timeout. Visibility timeout means if you have set a particular timeout, and after that timeout expires or after that timeout goes, you will not able to see the message in the queue, means it will get expired from the queue. After that, you can delete the message because you don't want the message to be deduplicated and these things. So you delete the message so that any other person cannot use it, and you can delete that message using the message ID. And once the message has been consumed, you get a receipt of that message. So with those parameters, you can delete the message. So how the process works is that consumer will poll for the message. Once it says that, okay, from the queue, SQS queue, it will check for the poll for the message. Once it sees that, okay, message is there, it will process the message. Once it is process the message, then only you will see that message in your queue. Okay, so once you have saw that, okay, the message is there, after that you can again delete the message so that it will not get the same message again and again. Otherwise, if you don't delete the message, it will keep on processing again and again. Now, visibility timeout, it is very important feature, and most of questions, as I said, that we get related to visibility timeout. So they basically say that, okay, we have sent out the message and this message has been received, but again we are seeing the same message, or after this first time we don't see the message, and if we have not received the message, that could also be the factor. In those cases, you have to go and you have to increase the visibility timeout. So what is visibility timeout? That when consumer polls the message, okay, so to prevent the messages from other consumers, so that other consumers or other consumers which are related to that queue, they cannot see that particular message after a particular time. You set the visibility timeout. The exact definition we have written it here, which says that a period of a time during which Amazon SQS prevents other consumers from receiving and processing the message. The default is 30 seconds, minimum is 0 and maximum is 12 hours. You can set. Now, you set it between 0 and 12 hours, as I said, and then the default timeout for this is 30 seconds. If you set it too high, that is, let's say 15 minutes, okay. So what happens that consumer, like sometimes it fails to process the message. It might see that, okay, message is there, but it is not able to process it. Okay, because it has to wait for a time and it has to like again re-poll and reprocess it. By the time it is trying to process that message, it does not receive the message, or it, when it polls, it gets a new message. So it tries to pull that new message. Okay. And if it is too low, so because if it is too low, like 30 seconds and all, so in that case, ideally the default time is 30 seconds, but consumer needs some time to process the message. Okay. When it, here we are talking about a scenario where you have a lot of messages in the queue. Okay, not one or two, but when you have a lot of messages in the queue, at that point of a time, it takes at least of 2 minutes to process the messages. So in that case, what will happen that the consumer which actually has to receive the message, instead of that consumer, some other consumer will get the message, and means that message is being processed multiple times, because 30 seconds is a very low timeout, and you see that the process of message processing time is keep on increasing. Okay, it is say processing the same message again and again. We'll see it in our demo that how actually it do that. Now there are two API methods. One is a change message visibility and one is a delete message. So when you work mainly for the developer point of view, if you have a change message visibility method, you allows you to change or increase or decrease the visibility timeout wherever you want to do, or you can do it from console as well. And delete message allows you to delete the message once it has been successfully processed. Normal scenario, once the message has been processed, you should delete the message so that no other person can consume that particular message. Then we have a dead letter queue. Dead letter queue, what it says that if if your consumer fails to process the message, so first time it fails to process the message, so what will happen? It will go back to the SQS queue, again poll for the message. So it gets a message because message is still in queue, it has not been deleted. You have not deleted the message, so it has not been deleted, and it will again check for the message, again see, and it is trying to, let's say 3 times it tried and it fails. So there is a failure loop where it says that, okay, 3 times it tried and it failed. So it says that, okay, it is failing again and again, put it into the dead letter queue. Okay, this is a different queue, put it into the dead letter queue, means that these messages cannot be processed, so that you can basically check your dead letter queue and you can find out that what all messages are not processed, or if any message is not processed, you can see that if that particular message is in your dead letter queue. So if consumer fails to process the message within the visibility timeout, then message goes back to the queue. And you set the threshold at how many times it can go back to the queue. So that is known as a redrive policy. Redrive policy, which basically says that, okay, how many times the message can go back. Once this redrive policy threshold is exceeded, then messages goes into the dead letter queue. And so you have to create the dead letter queue and like basically to assign it to your SQS queue so that it can do that. So once the messages are in this, so you can, what you can do that before these messages expire, before the retention period, which is default is 4 days, you should go ahead and you should process this message. Okay. Any question here? So let me first go to the this screen and let me show you whatever we have learned by now. Just log into the AWS. So let's go to SQS, simple queue service. Yes. So as we see that this simple queue service fully managed by AWS, a messaging queue service. So if you see that it basically the benefits is ensure high availabilities, reduces your cost and these things. As it is a fully managed service, so there are no fixed expenses then. So if you click on this, get started now. Okay. Now, if you click on this, you have to give your name, the queue name and these things, and you basically it talks about that what type of queue you need. So if you see that standard queue, so it gives you the unlimited throughput. Okay, means that unlimited number of transactions per second for like basically when you talk about the per API actions, like for each API action, if you want to send out a message, it supports that. A message is delivered at least once, but occasionally more than one copy of message is delivered. Means because as I said, there is no guarantee, and the if within the visibility timeout it expires, it sends out the message again and again. So this is how this messages will go. You see that this message again, third message is being processed. These are the things. Okay. So best effort order means it tries to send out in a best effort in the order, but it is not guaranteed that the messages will be delivered in the particular order. So what it do that it sends the data between the applications when the throughput is important. Example. So let's say few of the examples. So one is the batch messaging. So when you do the so when you want to when you are processing different kind of messages. Okay. So in a batch means when you are sending a sequence of 10-20 messages, that is like known as a batch messages. So for those kind of scenarios you can use this. Okay. There are like for credit card validation requests you can like allocate this message service that's stating that okay the user has validated, then everything is done and at the end the transaction has been processed. But that way once the message has been received, and again it says that if you upload some media or these things, so on those kind of scenarios also you can use this. So there are different ways and mechanisms by which you can use the service. Now there is another important term is the polling, because consumer it's poll the messages. So it polls in a short polling and a long polling. Okay. So there are some of the so short polling means like it is polling for a small period of a time, and long polling means like it will poll or it will wait for message for more time. But there are few of the limitations of a few of the problems with the short polling. The first problem with this, that it queries only the subsets of SQS servers. Means it does not query all the servers at a time. It queries subset of SQS servers at a time. So it takes lot of time to get all the messages which are there in the queue. Okay, that is one problem. So because of that, it says that it needs to make lot of receive message requests. So it needs to send out lot of receive message requests so that it can get all the available messages in the queue. And sometimes you might get empty responses also, because if there is no message or something, so you might get the empty response. So to deal with these problems of short polling, there is a concept called as long polling, which is preferable to short polling. So because here your waits time can be 1 second to 20 seconds. Okay. And it decreases your number of API calls, or it decreases your number of received message calls, so that you can get all the messages. So what are the benefits? That first, it for the benefit is that it queries all the SQS servers rather than querying the subset of server and taking and getting a like these small less number of messages. It query all the SQS servers so that it can get all the message. Here this receive message request is increased, but here that receive message request is decreased, as it queries all the servers, so it receives all the mess. It does not have to make too many receive message calls, and you don't get empty responses when you work with long polling. So always long polling will be preferable option, as it gives you more benefit than the short pollings. Okay, I'll share this 6 pointers with you in a different document in Drive. Highlight. So this is how like it keeps on polling, and once it polls, you see that for the message. So the message is there in the SQS queue. It keeps on polling, and when it sees that okay message is there, then message will come and be basically processed to the consumer. So this is the concept of the long polling and short polling, which is actually related at the consumer end or the consumer level. Now, whatever we talked about, so let's see the entire diagram in the one flow. Okay, here we have the producers which are sending the messages. We can have many producers which can have different consumers. These messages will come and get stored in SQS queue. Now SQS queue, as I said, long polling is preferable. We are here, this message is like this, basically consumer is polling for the messages, and if there is a delay of some second and also some delay would be there, and you will get message after that time, and long polling will get to know that okay, now all the messages has been delivered, and it will deliver it to consumer. Once it got the message, it has processed the message, consumer received the message, then it can go ahead and it can delete the message. Okay, now if message is not like let's say the visibility timeout expires, then message will go back to the queue. Okay, messages the visibility timeout is expired, then message will go back to the SQS queue. Now apart from that, if again and again if the message is going back to queue and if it is not able to process it, what you will do that you will say that okay, assign it to the red letter queue, so that you can see that whatever the problem or which message we have a problem, you can go ahead and reprocess it before that message gets expired from the dead letter queue. That is the record retention period of the 4 days. Okay. Any question here?
Nope.
Okay. Good morning, Prasad.
Morning.
Yeah. Okay. So let's move to SQS FIFO queue. So this FIFO queue is a new service. Okay. FIFO, we have two types of queue, standard and FIFO, and in which between we have a delay queue. But FIFO queue is a new service, so it is not available in all regions. Okay. Mostly like it is available in Northern Virginia region, I think for now, but it is not available in all region. And it is like service recently came in, so you don't get much questions with respect to the FIFO queue. Okay. Or if you get also, it would be very straightforward that you need a lower throughput, or you need the number of the messages which we are sending there in the order. So some kind of a hint which you get actually, which will be a very direct hint, and that will tell you that okay, this belongs to the FIFO queue. Now, as I said that there we have the no limit, okay, in the standard queue. But in FIFO queue, we have a limit up to 3000 per second with batching, or 300 messages without batching. What does it mean? That you can send 10 messages at a time. Okay, so if you do 300 into 10, that will go with the 3000 per second with batching. Otherwise, 300 messages without the batching. Messages are processed in order and they are sent exactly once. Means there is no redo. Like if it would be a duplication, the duplicate message will be there. It will deduplicate it. Okay, so there is no duplicate messages which you will be receiving. Now there is no delay message. There we saw that delay, the delay seconds kind of a thing where you can delay the message. Here there is no delay. Here, once the messages are received at a queue, or once the messages are in queue, then you can delay it from queue actually. Okay, like there also you are delaying it from queue, but you are like consumer will not able to poll only, or not able to see those messages. Okay, here consumer will able to poll the message, but it will not process it because the queue will be delayed to release those messages to process it further. Anytime you write the FIFO message, okay, so you have to give the extension as .FIFO. Means let's say if you are writing that my message, so you have to write my message .FIFO to denote that this is a FIFO message. Okay, and as I said that deduplication concept, because messages are sent exactly once, so there is a deduplication concept. Let's see in demonstration that how it looks like by creating a standard queue message. And before that, let's read about the FIFO queue from AWS documentation as also. So it says that it supports up to 300 messages per second, 300 send, receive, or delete operations. And when you batch 10 messages per operation, maximum that with 10 you can do. It supports 3000, that is with batching. To request a limit increase, file a support request. Means if you have more messages of these things, you have to create a support ticket so that they can guide you what to do. Order of messages will always be the same. So it will, you see that it will be a sequential order, whatever there's there, and one message will be processed only. and no duplicates are not introduced into the queue. So it says that if you have some like user entered commands or something, if from EC2 instances, if you have sent out any command or something to SQS which has to go ahead further to the Lambda function or some other thing, so you can use that, because those commands should be executed once only. You can use with that way. For a product price or these kind of like price modifications or these examples, you can use it. Or it says prevent a student enrolling in course before registering for an account. So means if you are not registered for account, you cannot go enroll in the course. So we are going to create a standard queue message. Let's go to configure queue. When we go to configure queue, what we first, let's type our my first. If it would be FIFO, I would write it like this, dot FIFO. However, I have to select dot this FIFO also. You say a FIFO queue name must end with dot FIFO suffix. So if I say that dot FIFO, that error will go. So this is my standard queue. Here you can set out the default visibility timeout, which is nothing, basically your length of time message received from queue will be invisible for other consumers. As I said, that values from 0 seconds and 12 hours, so you can set anything, but you should set any such value so that consumer can able to process. It should not be too high and it should not be too low. For our lab purpose, we'll use the default one. Message retention period can be between 1 minute and 14 days, and you can select anything. Default retention is the 4 days. Message size is 256 KB. That can only be there. If you have to again do any other thing, you might have to raise a support ticket. And apart from that, SQS Amazon accept only 256 KB of the message size. However, that is just the message body, and 256 KB is quite sufficient enough to handle the message body. If you want to delay the delivery, so you can delay the delivery of the message. And receive message wait time means that the long polling, basically this is there, the long polling concept. If you want to concept, you can put that. That is as I said, that long polling can be done up to 20 seconds so that you can get all the messages. But in our case, will send one message only, so let's not configure that. Now if you have to do this, so you can say that, okay, first you have to click on retry policy so that you can set out the threshold. Okay, you can give the dead letter, like you can give the queue name so that it can go back to your queue name. So here it would be my, like this queue or whatever queue you want to give the queue name, and how many maximum number of the messages it can receive in a queue. You can put that basically limit is 1 to 1000. You can definitely encrypt it with the server side encryption settings, or with the if you do with SSC, so with your CMK or existing CMK, you can put it. Now we have configured everything. Let's go ahead and let's create the queue. So we have created a queue which is of a type standard. If it would be FIFO, you will say FIFO. Content based deduplication will be applicable for the FIFO, not for this. There are no messages. There are no messages in queue or something right now. It is created at this time. Let's see few other concepts here. Yeah, so you can, like, this is the basically like the URL of your message. So here also you can go to this URL and you can see the, like, from this endpoint you can use in the Lambda and these things to trigger the messages. ARN you can do if you want to give it a security based on the role wise and these things, you can give that. Apart from whatever settings we have done, that thing we can put it up. Permissions, if there is any permissions and all you want to apply, you can do. Retry policy we have not put. A default monitoring is done. Apart from that, you can like set up the monitorings in the CloudWatch also. Encryption and these things are there. Lambda trigger means if you are integrating your SQS further with the Lambda, you can you will get that whatever the Lambda functions you have created, you can get to know those names. So fine. So let's try to do send some message and see. So if you want to configure again queue or something, so you can like change these settings from here. So you can even subscribe this queue to the notification so that if any message is sent, you can get notified. Now, as I said, when you have to send a message, that is the producer end. So you will have two parameters. One is message body and one is message attribute, where message attribute will be your optional field. Let's say message body. Let's say that hi, this is cloud batch. Okay. If you want to delay the delivery of the message, you can put that. Let's not do that right now. Let's define one this my first message. You can put the string number of binary. This is this. Value is my first message. So click on add attribute and it will add the attribute. Now you click here send message. As soon as you click on send message, it says that it may take up to 60 seconds for message available column to update. That is, here you will see the message available column, which will update in 60 seconds. That is 1 minute. You will get the message identifier and the MD5 for a body as well as MD5 for the attribute. So I told you that the return type for the producer will always be your message identifier and your this. When you are working from console, these things really doesn't matter too much, but when you are working from APIs and all those things, then you have to capture these message identifier, or when you are working from CLI, so that if you have to do further processing or do some operations for a particular message, you can use that particular identifier or the MD5 for the body. Okay, if you want to send another message, you can send. Let's close this. It is refreshing, and now we see that we have one message available. Okay, let's go to view and delete message. So right now, before to view the message or do this, first of all, you have to start the polling. Okay, once you will start the polling, so whatever the message will be there in the queue, those will be displayed to you. And once you don't want to like consumer to poll or these things, so you can stop the polling. Okay, let's start the polling. And it says that, hi, this is what we get. Okay, let's click on more details. So we see that this was my message body. This is the details. This is my message attributes. Okay, my message size was 42 bytes. And I'll close this. So it was a receive count as 1. Okay. So you see that this is polling at this 0.5 receives per second and message one others. So let's stop now. It will not process any further message. So we have one message available. If you want, you can send another message. Just send a message. And now this time I have not defined any attribute, so I'll not get any attribute. I immediately got second message. Let's click this. Let me start the polling. Let the polling be there. Let me go to send message and say, hi, this is Saurabh. Send a message. Close. It says messages available 3. View message. So as a gap closing this, it will like from backend from API when you work, you can basically see this. And you see that the receive count of this has been 2 because this has been processed 2 times. As I have not deleted, like they are not configured for delete message and these things. So it has configured 2 times and all the messages are being processed. That is what deduplication matters, that whatever these messages it says that are there in the queue and have not been deleted from queue, it keeps on processing all the messages. That is the problem with the standard queue things. Okay, let me stop polling. Okay. So if I delete any message, it will be like you can go and you can delete the message. Yeah. So this is all we have here. Any questions, guys? Now I will delete this. So if you also do anything, you have to delete this because this service is not free. I believe it costs you for a free tier account also. So I'll delete this as soon as I'm done with my work. So for free tier account also, I think it costs you. So I am deleted this. Okay, so this is the complete SQS service, but this is the complete role of my SQS service, which basically gives you the message delivery and these things. Normal use case and these things are is that when you basically configure it with the EC2 instances and these things, so that you can, when you actually come work on the project and all, where you have EC2, where you have CloudFront, Lambda, and these all things completely integrated. So you want to basically check that like the kind of a login level where you want to see that, okay, from which particular components and things it has been passed, or if you want to send out some command or send out some instructions so that it reads out that, let's say that if you want to send out the instruction from EC2 instance that the user has been verified or user has been authenticated, and Lambda should read out that message, and then only Lambda function should be invoked. In these kind of scenarios, my SQS and these things are like used actually. Now let's talk that how can you use SQS with the auto scaling group, as it is scalable and these things. So when it is with the auto scaling group, so how it is used with auto scaling group is that, let's say you have a EC2 instance, and that EC2 instance is attached with your auto scaling group. Now when it is attached with the auto scaling group, so EC2, like SQS will poll for the messages which it has to get from the EC2, but you have to define a custom metric in the CloudWatch, which would be like calculated by the length of your queue divided by number of instances. Okay, this is the formula, queue length divided by number of instances, and based on that you define a custom metric, and you say that if my CloudWatch alarm has been breached, okay, if my CloudWatch alarm has been breached, then scale the instances. Means that if I'm getting so many messages and so many things, so if this particular thing has been breached, so I need to scale up or scale down whatever it is there, you can do that. So you can ideally go ahead and you can define which kind of a scaling policy you can define in this. Can anyone tell me? Based on the metric, custom metric, I'm like getting the alarm, and accordingly I am going that. Obviously you can define any kind of a scaling, but what would be the most preferable way you think?
Sorry, Sachin, can you repeat the question?
So I'm saying my EC2 instance is continuously like polling for, like SQS is polling for the messages from EC2 instance, and it is checking that whether when it says that, okay, a lot of messages are coming in, so I have set up one custom metric in CloudWatch which basically which basically uses the formula as queue length divided by number of instances, and sends me a notification for the alarm breach. In that case, I have to scale up, scale down my EC2 instances. So that's how like I can use auto scaling along with SQS and CloudWatch. So in this kind of scenario, like where I have to scale up and scale down based on the this alarm breach, what would you think that would be more better option to a preferable option?
You can have a CloudWatch alarm that can pull the SQS queue and check the depth of it.
No, I just want to know that what kind of auto scaling policy you will configure it in this scenario. Let's say if my alarm has been breached and I have to increase the instance, or then if my alarm has like, if my alarm is, let's say, low also, like lower than the threshold, then in those kind of scenarios, if I have to scale, so what would be the best scaling policy I can attach it?
Normal target tracking policy.
That is also fine. Any other policy which we can do apart from the dynamic and these things? Like dynamic definitely we are not going to do.
Step.
Yes, so step scaling is also one more, because you are going to increase one instance most of the time, like with that way or these things. So you can define the step scaling policy in this kind of scenario. So this question comes sometimes in exam where they ask you when like you have attached with the auto scaling and these things. So what kind of a metric you will define in CloudWatch? So always remember, there is no such metric defined in CloudWatch, no such predefined metric given by AWS. You have to define your own metric, which is a custom metric, where you basically apply the formula as queue length divided by number of instances. If anyone wants to make a note of this, please make a note of the formula. Okay. So this is all about my SQS. Now I'll move to Amazon Kinesis. That is another service which is very, very important and very, very useful service when you talk about analytics. Okay, it's mainly important service when you talk about the analytics. So Kinesis is one of the service which basically collects like whatever your data, whatever your logs or whatever you want to do. So it collects even videos also. It collects them, process them, and it analyzes that real time, that particular data or so that particular information in a real time. Okay, so it streams your data wherever you see in exam real time streaming. Okay, there you will go ahead with Kinesis only most of the time. Okay, so that is your uh, that is the purpose of the Kinesis, to collect, process, and analyze real time streaming of a data, so you can get timely insights and react quickly to a new information. It is a cost-effective process, and as it is completely managed by AWS, so you don't have to worry about a lot of things. It is highly scalable, as well as you get a real-time processing. So you just ingest your data, and it will like just a buffering and these things, which normally happens with the video streams and mainly the media streams, and it processes that in a real time. Now there are there are four main kind of a streams which Kinesis or which AWS Kinesis offers. The one is Kinesis video streams, then Kinesis data stream, then Kinesis data firehose, and then Kinesis data analytics. Now, Kinesis data stream, data firehose, and data analytics combinedly together makes it as a Kinesis streaming data platform. Okay, it makes it as a Kinesis streaming data platform. We'll talk about each and every of the streams separately. Before that, let's just understand that what does it do. Kinesis video stream is for the videos, mainly for the media. Data stream is to collect and process the data and collect the data and process it. Data firehouse basically transforms and deliver that particular data, and data analytics is toward the analysis. Sometimes in exam you get the question, and just a minute. Sorry. So data streams, yeah. So sometimes you get in exams, you get the question where they basically confuse you with the options of giving Kinesis data firehose or Kinesis data analytics. In these kind of scenarios, you should understand that what is actually the use of, or what actually is being done in the use case or the scenario whichever is given in the exam. Okay, because if it is talking about just the collection and the processing of a data, you will go ahead with the data stream. Okay, if it is talking about somewhere delivery or of the data and these things, then you will choose with the firehose. If it is saying that they are performing the analytics and these things, then you will go ahead with the analytics. And if it is talking about only the video stream, that is audio and video files, then you will choose with the Kinesis video streams. Let's see these capabilities one by one. Now, Kinesis video streams, it helps you or it allows you to capture your large amount of audio and video data. Okay, so basically what you do that it captures your large video as audio files, okay, from a different sources, and it processes them. Okay, a very important like very good service which you basically use it because it offers you the data durability, it gives you the encryption and the indexing concepts and all those things. It is a serverless, so there is no infrastructure and these things which you have to manage. And you can create the streams and these things from the console itself. But we will see the but you mostly work in this with the SDKs or with the CLI. I will show you in the lab that how we do this. Okay. Now, how it works is that you will have a different sources. Again, guys, it is again the work on the producers and consumer model only. Now you see that this is AWS SDK symbol. So all this is happening via the AWS SDKs only, okay, or via the CLI only. Now different producers we can have. Okay, we can have mobile apps, we can have the webcams and the normal like mobile cameras which you put for the monitor, CCTV cameras, and the mics or the microphones and these things. You get the media files from these three sources mainly. So you will get these. So these will be your producers, which will produce the media files and send out to video stream, Kinesis video stream. Okay, that is, it will ingest the data to Kinesis video stream. Why I'm talking about ingest and I'll talk about ingress keyword, because in exam you get these keywords in the options that it is I'm ingesting the data or these things when they talk about Kinesis and these services. And then it will, the consumer will basically process those data in the EC2. Okay, it can process like in a batch format, in a continuously Like it will stream a particular part and store it in a EC2 instance. Like this way, it can store in the EC2 instances. So this is the working of the video stream. Okay, which basically like we'll see like if you get any data or these things, and you can process it for your real-time streaming. Okay, to real-time stream and to store it in the cloud. Now we saw that producers, consumer, and Kinesis video stream, these three terminology in previous slide. Let's understand these slides, these terminologies one by one. Producer is your source, which basically puts your data. Okay, any video generating source would be your producer. Now, a single producer can generate one or more video streams. So it's not important that only there should be have a multiple, because your a security camera or CCTV camera can generate both your audio as well as video. So you might be, and when it's stored, so normally you see that the MP4 and these days the chat files and the other files are, there are capabilities where you can store them in a different, like when you download a tool, so it allows you to store them in a different formatted, audio only, video only, and chat only. Even Zoom also do these, that kind of a like feature Zoom also has. Now, so you can have multiple streams from a single producers. Now let's talk about consumer. Consumer is your destination, which basically gets the data, or the, if it is in a going in a buffering mode, and like anyways it will, entire video will not be processed. It will probably process like in a buffer only. If anytime you have uploaded a video on YouTube also, you might have seen that when you upload the video, it will upload in few seconds. Like if, until you have 500 MB of a video, it does not take too much of a time. More than 500 MB of videos, it takes a couple of time to, sorry, few more minutes to upload. But to process, it process very slowly. What, like if it is a very large video, then sometimes it takes like 2 hours to process those kind of videos in YouTube. But for a shorter video also, it takes 10 to 15 minutes. Because why this particular process takes a time? The reason, because when you, it actually processes the video frame by frame. Okay, we all would have a little bit idea about the audio and video, as sometimes these days most of people, they create videos and edit it and all. So you can, it does all those things by a part by part or by frame by frame. So in that way, consumer will get the data at a destination. You can view it, process it, and then further whatever you have to do, the analysis and all, you can do that. Okay. Now, Kinesis video stream, this is your middle layer, okay, or your basically your main component, which does all the activities, that is getting the data from producers and further processing it to the consumers or to the destinations. Okay, so this is basically the resource which enables you to transport your live video data, or like if you want to store it for a particular time, you can store it, and then it makes your data available to the consumers. Okay, now this can carry like audio, video, or whatever the encoded data streams would be there in that. And you can have a different like each applications can have a different Kinesis video stream attached to it, and they all can run simultaneously. Means they all can stream the data in parallel. Okay. And at a time, like most of the time, only one producer will be publishing the data. It's not that 3 producers are attached, to all 3 are sending the data and it is processing. So one will process, then second, then third, like that will go. Let's see this service here in the console before moving and talking about the next service. So what we see as per AWS, that easily collects, process, and analyze data streams in the real time. Okay, you can go ahead and you can configure Kinesis data stream, data firehouse, data analytics, whatever you want. Okay. Then this is how it says that it works, that collects streaming data, process and deliver it, and then analyze it. Okay, so for each and every process, you have to create the data stream, you have to create a delivery team, and then wherever you have to create the analytics and all these things, for that you have to create the application. Benefits are that real-time data capture is there. It loads your real-time data, so you don't see any lag and all. Every time you see the real analytics, and you can get the insights and these things for those things. So, like most of the these days, like there are a lot of things when you have to, when you have a like the applications or something where you are like really they are like building up a lot of important, they're getting up a lot of data in these things. So in those kind of scenarios, what you do, like you want to have a real-time analytics and these things. So you can build up, you can use this particular service if you are using a cloud. Okay. Or you talk about the cricket match and these things. So there also, this Kinesis would be very, very efficient service, because there you do all the live streaming of the video and these things, as well as they will keep on performing the analytics, and you see the score margins as well as the other things. Okay, so these are the few of the use cases. Like even Netflix also uses this particular service to monitor the communications and all whatever the things it has. Apart from that, it says Sonos is something, Zero is something they use. These are some of the companies which they use this. Okay, so they have like the pricing. So shards we'll talk about in a couple of minutes. We'll talk about shards. So for shards, they have just 15 cents per hour, as well as for put payload units, like whatever data you are putting up. For that they have, for a per unit they have this one. For data firehose, they have the pricing model, that is whatever data ingested. For the first 500 terabyte is this, next 1.5 petabyte is this, next 3 petabyte is this. It's on a monthly basis per GB. And data format conversion, like whatever to format you are converting it further, for the as you are doing transformation here, so you will use that. For analytics, it is, this is the pricing model. Okay, so any questions here? Okay, let's talk about, yeah, let's talk about next stream then. There is Kinesis data stream. So it, video stream collects mostly the video, like important for mostly the video media related file. Data stream is mostly for data records and these things, when you have a large amount of a data, or let's say you are working in a, I talked about a live scoreboard and these things. For those kind of scenarios, you can use data streams. Okay. Now, again, cost effective, and again, like as managed by AWS, so all those factors would be there. Okay, durable, elasticity, and these things will be there. Now you can start consuming the data from the stream almost immediately after the data is added. Means as soon as producer has added the data, immediately it gives you real time, it start giving you the real time that data whatever has been added by that. Okay, it is mostly like useful for the big data related service, where you have actually very large amount of data, like when you talk about petabytes and terabytes of a data. For those kind of scenarios, you can use that. Or it also is important that you can process the data from here, and if you want to store it on premises, so storing this much of data, you might be using the data warehouse or these things only to store that much amount of data. So how it works, you will have the different producers. So it could be like you can get the data from any of your mobile application, any of your on premises applications or servers or EC2 instances. Once that is there, so Kinesis data stream does its operations. I talk about shard in a couple of minutes. So it basically creates shard, and these number of shards are there, and with which it basically transform and process that data, which is which will be sent out to the EC2 instances, and from there you can store your results into the any of these services. Whether you talk about, you can store it to the Kinesis Firehose, you can store it to EMR, you can store it to Redshift. So you see, as I talked about the map reduce and data warehouse, that's the reason they have used Redshift and EMR as well. Okay, DynamoDB, because you don't know what kind of data would be there. So it, as DynamoDB performs a NoSQL, so it would be good to store in this any kind of unstructured data. And S3 for any, again S3 would be our storage. So you can store it at any particular place. Now, let's talk about, so producers, consumer, we already know. I'll not like repeat it again. If you want, I can repeat it, but they are like source and destinations. Retention period, first of all, let me talk about retention period. Retention period for this is default is 24 hours. Okay, and you can like maximum can go up to the 7 days. Basically, length of the time your data records can be accessed from your stream. Okay, so for the time period for which your data can be accessed from the stream, that is your retention period in this case. Data stream is nothing, it is set of shards. Now let's talk about shards. So shards are nothing but whatever the sequence of data, whatever the data will not go all together, right? All terabyte of data will not go together. It will go in a particular sequence wherever the backend logic AWS has put. So it will give some unique identifier and the value. So all those unique identifier records, so combination of all those actually in the stream form a shard. Okay, it has basically it works on a fixed unit capacity. Means whatever the data will be there, after that when it has to process further to consumers, so you can read that data for up to the 5 transactions per second. Means that 5 units per seconds for read. And that goes to maximum data read of maximum total data you can read at in per second is 2 MB per seconds. Okay, that is your 1000 records. Means 5 transaction per second, or it says that 1000 sorry my bad, 5 transactions per second for reads, or total data read rate could be, read rate is will be 2 MB per second. Means 2 MB of a data can be read per second. With that, when something is being like written for, you are writing some data or some performing some write operations, at that time you are going to put 1000 records per second. Okay, it goes like 1000 records per second for writes, and maximum rate would be 1 MB per second. Okay, and writes is including partition key, because sometimes you create the partitions of the data when you are injecting it from the databases or these things. So in those cases, including the partition key also is there. So shards is, what is shards? Ideally, you just consider that it is a group of your data records, group of your unique data records or unique index data records. Okay. So because it is create some, it will give some each and every some different UID or a different unique identifier number. All those will be clubbed together and it will be put in the shard. And those shard combinedly, like whatever the shards are there, so it will have a fixed capacity. So means in one shard, it's not that all the 2 terabyte of data will be stored in one shard. It will create multiple shards. That's why they have a read capacity unit and fixed capacity unit. And based on that, the combination of all the shards will create your Kinesis data stream. This shard one we will be seeing in our lab exercise once we will cover up the other 2 capabilities. Any question here?
Sachin, this shard concept we have only for data stream?
Yes, only for data stream.
So yeah, maybe I'm not very much clear with why do we have this here in data stream, like the actual
No,
purpose
so
of
it
having.
has to, yeah, so it has to process it. Okay, so AWS, like to process the data, if you see the video stream, so in video stream, they are not, like in video stream, what they have that in Kinesis video stream, the backend or the middle layer, which is there, it is like taking the, as producers will produce only one, like one data will come. Okay, one social media, sorry, one video file will come at a time. Now one video file will come, it has to process one video file at a time. So it will like go in a sequence order. But in data stream, what will happen, that different producers are sending the data. There is no such limit that, okay, one producer can only put data. Okay, like you will keep on getting the logs. Let's say if you are getting the logs, you keep on getting the logs. Now you got one set of log, you got two set of a log, you got three set of a log. So to differentiate that, so that it can further process it properly, and then it gives it to the consumer, it has to put up like the all those logs in a unique way, right? So that it will not mix up those logs. That's actually the concept like behind putting up of the shards in by AWS. So that is their own term through which they work. We will mostly concern while working with this is that when we are putting the data and doing these things, so we get some shared iterator ID and these things which we will see in the lab, so it can process that.
So is it helping to like identify the messages from different producers? Like
Right.
messages from one producer will be grouped into one shard.
Yes, yes, you can say that. You can say that. It
Okay.
basically like your, it acts like the throughput unit, you can say, because you will control the read and write operations, right? So it will, you can put that. You have to specify that how many, you have to specify that how many shards you need to create your data stream.
Okay.
Not clear, I guess.
Uh, yeah, like I can only think of like group the incoming messages so that it
See,
can be differentiated?
yeah, okay. See, you are getting different kind of a data. Okay, you might get different log. Okay, you might get something you are getting. Let's say you are getting from social media. Okay, something you are getting related to payment logs. So you will create one day chats or one this thing for related to this application logs. One related to your social media related. One related to your this. So it will uniquely store all your data right in the stream. So just to segregate with that, we are using this shared concept here.
Okay.
So Sachin, do we need to create it one time, or it will be for per request? The different
No, you
shard.
create it. Yeah, you create it when you configure the Kinesis data stream. At that time, you create it.
Okay, so it will be. Let's take an example that I'm getting a data feed from some Facebooks, and then I'm also getting a data from some banking services. So there will be two different shard I need to
Yeah,
define,
let's
right?
say now. So basically, so see, as I said, it's a throughput unit, right, for your data stream. So now you are whatever. Let's say you are getting 100 MB of a data. Okay. So as it has the as it has the this thing capacity. Okay. You see that it has a provided a fixed unit of a capacity. So you have to analyze based on the data size actually. Okay, you are segregating the data, but what kind of a data how much data you are getting, based on that you will create the shard.
Okay.
Means one shard, so one shard can write up to 1,000 records. Okay, so let's say that now you are getting some 10 MB of a data. Okay, and you know that okay we can read 2 MB per second, so you will create 5 different chats for that particular data, so that it can store, because it cannot accumulate 10 MB of a data together, right?
Yeah. Okay. Got it.
Okay,
Sachin, what is partition keys?
partition key, like you when you have large amount of data in these things, so you like create in like in databases mostly we create the partitions, right? So it is talking about that here, that it in like when you are writing the data, and if you are like just writing one partition at a time, so in that 1 MB per second, it's not that for that partition let's say if you have 10 partitions, so for each partition it will be 1 MB capacity for the throughput. Like it will include like all that entire partition keys will combinedly together will have 1 MB only.
Basically, if I understand it correctly, I know you're talking about database shards, but thing is that database shard. So this data basically, when we say streams, what I can understand, these are some IO operations which happens real time. So
Yes,
there is no storage which is needed to store this data, right?
there is no storage. I didn't got it. Means
No, maybe we do not need any like a database or something to store this data because it's happening real time. So these
yes,
shards
yes,
are not, yeah.
yeah. It's not storing anything. It will like keep it. It will like whatever the things will be there. It will go and then process it. It's like kind of acting kind of a nodes only, where everything is happening and like backend logic is written in by AWS there. Okay, it is acting like a nodes only, where you are storing, or nodes or like host or like that only.
So is it wrong to say that each shard will be a single partition for me?
No, like yeah, to understand we can say that in complete data stream, each shard will be kind of a partition for me for my data.
Okay, and one more thing I wanted to check. So when we say we have created shard, so this is the data stream which we are using. So if I'm going after having this data stream, if I'm trying to analyze it with the third service, what you have called after Firehose,
Data analytics service,
data analytics, yes, Kinesis data analytics. So if I'm using that, and there are data which are coming in from some so how does it actually sequence the data? So say there are 5 shards, what you mentioned, for 10 MB of data. And now I have a like data analytics also being put into to analyze the data which is coming real time. So this the speed or how the transactions, how the messages are processed and read, that way how it will maintain that the real time data which is coming in is in order.
Yes, it actually maintains the ordered list of message, because see, mainly it has two purpose only. One, like throughput unit, like capacity, the IO which you talked about, and second is the ordered list. So ordered list of messages there. That's the reason it puts like shard 1, shard 2, shard 3 in the that way.
So, so does the producer also need to know that how exactly he need to put the data? Because okay, from
No,
our
no,
end we have put it.
we configure this in the stream actually. Okay, we configure this in the stream, data stream. So producer does not have any, producer has to just send it the logs or the data. Then Kinesis data stream do all these things, like features, whatever has to be done.
Because maybe I'm not able to visualize it correctly, or I'm missing something over here. That okay, so if I have some producers which are producing data, and I have 10 MB of data, I have 5 shards for it, and that producer is simply sending me the data. So then in that case, how do you maintain the order?
Sorry, can you
One-
repeat?
So say I am saying if there are 5 shards which we have created for a 10 MB data pipeline which is actually producing the data. Now, how we configure in our application that the shard should maintain the order, and the analytics layer should get the data in correct sequence. That
Okay. So see, now producers or whatever my source will be there, they will be sending. When I will be configuring the Kinesis data stream, at that time you will define the number of the shards, whatever the number of shards you want to put. Let's say like we have a 5 here. Okay. In that sequence, when you define the 5 number, so Kinesis data stream, like it will create, like now the set of these 5 shards will combinely together as a shard. Each will have their, like each will process accordingly, and then when it is sending it to your consumer, like then all the things will be in the same order, it will be applied and it will be sent to consumer. We'll see, like we'll have a demo, we have a demo for this. I'll show you there how it actually works.
yes, I think that will help. Thanks.
Okay, so let's move to the next one, data firehose. Okay, we talked about data stream and the video stream. So data firehose, what it do is that it basically delivers whatever your real-time data is there to your S3 or Redshift or Splunk or Elasticsearch. Okay, like until now we see that it goes to EC2 instance and then from there you are storing it, but it is sending the data directly to your storage services mostly. This service is important to transform the data like before delivering it to destination. Like if you want to do some kind of a transformation in these things, you can do with the help of this service. Right now you are just collecting and processing the data, but if you have to do a data firehose, so you can use, if you have to do some kind of a transformation, then you can use the data firehose. So how this work is that you are getting the data from a particular source, okay, and that data source will directly send the data to firehose delivery system. Now at that firehose delivery system, there are some transformation and things are working. Okay, so you are like transforming the record. Let's say that whatever you want to do the transformation, means that if you want to remove some unwanted fields or these kind of things, you perform those logics, and there it is like it, or it is like transforming the records. I've never used this service, I don't know that how it transforms actually, but it is normal transformation is that you are removing some ambiguous data or something, some fields which you don't want, and then it sends it to the destination bucket. Okay, it can send it to any of your Splunk or these things. From Splunk also you can like go ahead and you can perform the analytics, or apart from that you are storing into S3 or Redshift and these things, and you can do that. Or optionally it's saying that you can store the source records also. If transform fail or something happened, you can then store your source record into your S3 bucket as a backup. Okay, now you would be thinking that 3 services, 4 services are there, everything performing different thing. how we will, like when we have to do all the entire process, how we are going to do that. So in all the services, one thing is common, that there will be something will be there which will be sending the data source. Let's say you perform the first, like the data stream, you have collected and processed the data, data came and stored in the S3 bucket. Now you will use that particular S3 bucket for the transformation. Okay, means your source will be now your S3 bucket, so that it will transform the and it will store it to the another S3 bucket or whatever it has to store it. So this is how you can configure the Firehose and the data stream. And then to perform the analytics, you again you can directly from the Kinesis streams or Firehose delivery system, you perform the analytics and you store the result in the S3 or Redshift. Before that, let's see that it provides you the real-time analytics for the real-time dashboards and create the metrics and these things. It supports, like you can store the data from the data streams and Kinesis data Firehose. Once you have collected and processed the data or collected and transformed the data, you can process it further for the data analytics. And from there you can test your live streaming by, and you have, it supports the SQL code, so you have to write the SQL code and these things for that, so to store the results. So it generates real-time time series analytics, real-time dashboards, and create the metrics, where these are my streaming input, and this analytics is like nothing here. You actually write it is a SQL application code through which you perform the operations, and then you get the, like you get the output again back to the Kinesis stream and Firehose, from where you can store it in the results into the S3 and the Amazon Redshift. Any doubt, guys?
Yes, Sachin. So, Sachin, what is the difference Kinesis and Firehose?
Yeah.
My question is, I'm a bit confused with the description of Kinesis streams and Firehose delivery stream, because if I see your last to last slide, it says we can connect our producers to Firehose. So up till now, what I was looking at, if you see the first slide which you have shared for Kinesis, you are saying that this is the entire yeah, this one. So it says Kinesis streaming data platform. So what I thought, these are sequential set of processes which are happening. So one Kinesis data stream will always collect. So whenever I have anything to do with the collect, I will talk about Kinesis data stream. Then if I have to do a transformation, I'll say Firehose, and then and delivery also in Firehose, and then analyze. This is what I was thinking. But when I saw that the diagram or the picture which you were showing before, in that it says like all the producers are directly talking to Firehose, so we do not need a data stream, right? So are these services working in conjunction, or are these services like maybe we can use as per our demands, like whatever I need, I can connect that directly. So it all has the connectors to talk to the producers which are feeding the data.
Yeah, so basically what happened, that when this data stream and data Firehose, you can connect with your source, data source, okay, whatever the data source is there. But for analytics, what they say is that, because see, analytics is not allowing you to collect the data and process the data and then do the analysis, right? For collection process or for transformation, they have created the data streams and data Firehose. Means the main purpose of data stream is to like collect the data, okay, and to like process it. And similarly for data Firehose, we have the transformation. That's the reason for analytics, data analytics, what we are doing, that the producers would be, or the source would be data streams or data Firehose. Because whenever you do analytics, you don't send a raw data to that, right? You do some processing, you do some kind of operation on that data, so that that data can be useful to, so that that data can be like made useful to perform further analytics, or to get the proper output from that. That's the reason they have made data stream and data Firehose as the producers for that, so that with these
Analytics, I'm fine. Sachin, my question was primarily on data streams and data the Firehose which we have. So what is the difference between these two?
Okay, so the Firehose says that Firehouse says that you can load your data stream directly into the Firehouse. You can load your data basically directly into the Firehouse for the uh, processing, okay, or for transformation.
So where did the data came from? When you say data into Firehouse, so
The data source, so we have to define. Na? Here we have put this thing, right?
fine. Data source is fine. My question is, do we have a data stream putting the data to a data source and data source is fed into Firehouse? Is that the process? Or when you say data source, it is a generic term, like data source means the producer. It can be a camera, it can be it can be
Yeah, data source, I mean to say the producers only here.
so then it actually works like a data stream only, right? So then why do I need data streams? Because I'm not I'm not able to actually identify the difference between these two. And if it, like, on what basis I should pick data stream and on what cases I should pick Firehouse.
Okay, so I see. I'll share you one like document for that. Okay, I have something here, so I'll share you one document with that, which will give you the clear difference.
I think, Saurabh, one of the major thing is Kinesis data stream versus Kinesis Firehose. The one thing which I have observed is if you have to do a real-time scanning, then you choose Kinesis data stream. And when you choose a Firehose is basically when you don't have to do a real-time scanning, when you have huge amount of data and you can scan throughout the day. So that is where you use Firehose. That's the thing which I've got.
No, they both, yeah, they both are real time. Although, like what you are saying, that is near to real time.
Yes.
The Firehose which is there, that is near to real time. Okay, it's so like obviously few latency and things will be there in that, but it's not that they are not real time. They both are real time.
Yeah, but means especially in the questions which I've seen, so Kinesis stream is real time, and your Kinesis Firehose is near real time.
Yes, yes.
Yeah, and because usually in the questions they ask that okay, you have the data from coming from mobile device which is stored on S3, and you have to process the data later, or you have to process the data in the day or in the night time. So if you get such questions, then it's always Kinesis Firehose. And if they say that you are getting a constant throughput of, let's say, different trucks going on GPS location, and you want to track their GPS location and provide them the output, then it's real time. Then you usually choose your Kinesis streams.
Right. That is one. Yeah, that is one point. However, I'll share one document. So I've shared you something. Okay, right now. So if we can go through that also. But so I think Prasad is also referring from that particular place only. And I'll share you one. I'll share one more document to everyone, which will give you the clear understanding of this. Okay.
I just googled it and I've got some like information regarding this Firehose and Kinesis streams. So I just pinged it on the chat right now. This is something which I read. I don't know whether it's correct or not. I just read the first link only. So it says that Firehose can scale to gigabytes of streaming data per second and allows the batching, encryption, and compression of data. It is noted that Firehose will automatically scale to meet demands, which is in contrast to Kinesis streams.
Yes, that is correct. That is, it is talking about shards actually, na? Because see there you are configuring the shards in the data stream, where shards are you are defining the capacity like based on the how many shards you need based on the throughput capacity and these things. And here there is no such concepts. So that is why it is doing the automatic the auto scaling like on demand basis.
Correct. So I think what Prasad was mentioning, when we are talking about large data and which is already like which you are mentioning or Prasad, about a near real-time thing. So maybe we have a data source which is producing a large amount of data. Then I can go for Firehose delivery system to connect it and do analytics on it. And if it is something which is talking about a smaller data or something, then we can go for data streams. Is that understanding right?
Yeah, that is correct.
Okay, fine. Yeah.
I'll share 1-2 more use case for others as well, so that everyone can get the point here.
Okay. Yeah. Sure. Okay, thanks.
Okay. So let's talk about the Kinesis stream. So let's talk about the lab exercise for this. Now we'll talk about this data stream only. Let's create the data stream. Now you can estimate your shard this thing. So it's in like writing to the stream. So if you are writing any data or any record, so based on that you can see that how many maximum records per second are there. Let's say if you say 2048. Okay, so you have it says the kilobytes is given. So to do 1024, which is the maximum one. So it says the total number of consumers would be 1, maximum record written per second will be 1, and estimated number of open shards will be 1. Let's apply this value. It says that 1 shard will be there. If you put 2, so based on that, like maximum you can put 500 in a free tier account actually. So now this will be my write capacity and my read capacity for this. So I have clicked on create data stream. So it takes about around 5 to 7 minutes, I guess, to create this thing. Okay, and there are different producers, like with the help of which you can generate one is like with the help of SDK you can transfer the data. One is like they have Kinesis agent, so you can install that agent and like configure it. They have these KPLs, like the libraries with help of which you can ingest the data. Now you can configure the consumers from here, like these, either like to further process the delivery stream or the Kinesis client library or the data analytics. Then okay, it is good at this actor. You have the metrics here, the stream metrics, the defined, like it gives you a lot of custom metrics which you can do. So then in the configurations you can see the this thing. So that is one thing. Then enhanced fan out is like a new feature, like which came I guess last year only. Okay, so it basically improves like your throughput actually. So it's a feature which actually when you add it with your data stream, so it improves your feature, and mainly to scale up your consumers and these things. This particular feature is used. However, this came last year only, so like not much being asked and much being used also. Okay, but you can use it with the you can configure this fan out feature mainly for the to add more throughput actually. Okay, 1 second. I have to go to the So I will be using the CLI here, and with the help of CLI, I would be performing the operations. So I need to get the access keys. connect to CLI. So let me just I forgot the command. Can anyone remind the command to connect to AWS CLI from CMD? Prasad, do you remember the command? Sorry, I got it. No issues. AWS
No,
config.
I'm very bad in commands.
So it was AWS config. I was just not able to recollect that. Okay. So now here I have this. So before that, like I'll just use the AWS Kinesis help to see that what all options we have. So we see that we have add tags to stream, create stream. We can create stream from CLI, delete stream, describe limits, and a lot of other commands we have. Now we have created already one stream. So we'll use the Kinesis list streams command, list stream. So list stream command has the add tags, get tag, describe stream, then okay, it says list streams we have. Yeah, so this is my list stream, which will which has this option, which generates CLI and these things. So let me do list stream. I already have this string, but streams minus minus. Meanwhile, I have this data stream. Let's see this. Status is active. My first stream. Open shards are 1. MYM5RST This it is configured in US East 1 only. My region is also US East 1. Here more config. I have US East 1 only. Everything is correct. Okay, let's try to create the stream from here only. Yes. Minus minus stream name minus minus shard count. create stream minus stream minus name my second stream shard count one. Okay. It says the SSL validation failed. HTTPS. Okay, that is the reason it is not able to connect to Kinesis, because it has to connect to Kinesis via the HTTPS. Okay, but this is okay. This is the this is actually what you do, that you have to, like, if you have to get the data and if you have to put the records and these things, so you use the, like, to list whatever streams you have, you use this command kinesis list streams. Okay, or right now it is not generating any output, and I guess the reason is same because of the SSL certificate error which we are getting. And because if I say that AWS S3 list, so if you get a one forget any command, you can go ahead always with the help. Yeah. So AWS S3 ls. So if I have any bucket by any chance? No. Okay, so it's not connecting because of some SSL validation failure of HTTPS. Might be like some certificate things or something we issue is there. So SSL, if it is verified, it will connect to your system. So otherwise, if you have to work with the KNSS, you have to use this either via the system, via the SDKs or something, or via this one. So you can always go to AWS KNSS help and you can see. But AWS list streams is the command which will tell you that what all streams are there. Now to create stream, we already saw right now that you create stream by giving the stream name and this. If you want to describe your stream, so you basically do describe stream, and then you pass the parameter minus stream name, and you give it your my first stream which we created here. So you give that, and it will give you that here it will show you one more stream. Okay, apart from that, if you have to put any record, okay, let's say from here, if you have to put any record, so you say that put record, then you give to which stream you have to put record. So you give the my first stream, then you define that minus data, and you can write like whatever you want to do. So say users and hit enter, so this will be there. Okay, or if you want also, you can put the partition key also. So partition key, and let's select user 1 2 3, and it will put the record into the string. Okay, so it uses the so it says that invalid base 64 users, or it is not connecting with that, so it's SSL certificate. So that's why we are getting this encoding decoding issues also. So but normally will not get this kind of a issue when it is working there. So we'll get again the same error, I think, because of these stuffs. However, SSL validation failed, we got this time. And now once your record and once your data is there, so what you do, that you write the command AWS Kinesis get record to get any record, or before that you do one thing more, you have to get the shard iterator, because your records are stored in the shard. So you get this using this shard iterator for your stream name. Okay, my first stream, and this will give you the shard iterator. A JSON will be there, and you copy that particular shard ID and all those things, and then you get record, use the get record command of C, and here you write shard iterator and you give your shard ID, which will basically give you the record whatever you have put up in the shard. Okay, or whatever in the data streams. So this process wise, this demonstration wise, like there are a lot of things which you have to like you can see the developer guide and these things where you can find out that information. However, from a theoretical point of view, or from a normally from the exam and from architect point of view, you need to understand that this is the important service for the real-time streaming. Whether you have to do the analytics, it gives you the analytics and these stuff. Apart from that, it also gives you the data, and you basically like you can process and collect, like transform your data and these things. And as I said, I'll share you one detailed document where you with the commands, list of commands and these things, so that you can refer to that as a cheat sheet.
Sachin,
Yeah.
Sachin, just one question. Like there was one command which you were showing, which talks about increase or decrease retention period.
Increase or
Decrease retention period.
where in the kinesis.
Yes. If you say AWS Kinesis help, it will show you that.
So there would be if in the data stream it would be there. Increase stream retention period. This one you are saying?
Yes. What is this for? Because this is a real-time streams. So how can I increase the retention period? Is it storing the data anywhere, or do I need to provide?
Kinesis data stream you can store if you want, like for a particular time.
But for that, do I need to connect it with some like S3 or any other type of storage or file system to store the file? Because if I'm retaining it, how would I retain it?
Correct. That I have to see, Saurabh. So like I have like I don't have the exact idea about that. So definitely I'll see that and help you.
Okay, I just saw it. That's why I got confused. Like, what is this retention period? Okay, that's sensitive.
Help, I'm not putting in, this is giving me error every time. Yeah. So it says that which is the length of the time data records are accessible after they are added to the stream. Okay, means that so increasing means that how you like once they have added to the stream. So once you have added the data to the stream, then you can like basically like suppose by default if it is whatever the default time is, if it is going that time, so you and you want to collect that data after some time also, so you can collect that. However, as you mentioned that it is real time, so why really it is needed, right? Okay. Okay, then next we have the Amazon MQ. So MQ is basically like the again the messaging queue service only, which is like stands for basically like completely like Amazon managed Apache Active MQ service. It's like a fully managed open source message broker service. Okay. So SQS SNS, they are saying that it is a like it is using a proprietary protocols or whatever in the backend from AWS. Whereas when you have to use some open protocols, okay, or some other protocols like MQTT, IMQP, STMP open via WSS, please don't ask me full forms. I don't remember any of the full forms for any of them. But when you are using any other protocols for which other like applications or things are following the protocols which are listed here, and like that or any other open protocols, in those kind of scenarios when you are migrating to cloud, you don't use the SQS or SNS, but you use Amazon MQ. Okay. Amazon MQ, the work and the things is the same, that it like it also like it's creates a messaging queue, and it basically once it has created a messaging queue, it stores your data, or it migrates your application to cloud. Okay, and it runs on a dedicated machine in a high availability with a failover. Now it supports both SQS features as well as topic features. Let's see how it supports that. I'll show you there. Here you will get more understanding. Now, this Amazon MQ is the Managed Message Broker Service for the MQ, which stands for Apache Active MQ. Okay. Now, what it do that this service basically setups the message brokers in the cloud, or you can say the kind of a message queue only, with the help of which you can migrate your applications without rewriting the code, or without like writing any particular code or something. So how it works here is that now it has its own EC2 instances, first of all, to which you are migrating, which stands for MQ dot. Okay, and which has a different charges based on the region wise. Here, when you do basically, when you create the brokers and the message brokers, so for the production environment, for prod environment, you will be using active standby brokers. Okay, which has the durability like optimized storage. For single instance, which you use basically for the dev and the test environment, you can go ahead with any of the storage which you wanted. Okay, this active standby broker cannot use the throughput optimized one. Okay, and these are the some of the blueprints like which you can use, which they have auto configured. And if you move to next, so here basically, here this service also, if you in this service you have to give your the username and password to access your active MQ endpoint. It will give you active MQ endpoint. Okay, I'm first showing you what actually how it works, then like I'll go to the documentation as well. You can configure like the broker engine version and other stuffs here. Okay, so create a new configuration. You can set up the logins, VPCs, encryption like completely with this. And let's create the broker for now. Meanwhile, let's move to this. So this says that it is the managed message broker service. First of all, this is the open source managed broker service. Okay, for Apache Active MQ, and Apache Active MQ is what we'll see, which helps us to migrate migrate to a message broker in the cloud. Okay, means like message broker is something like through which you can you don't have to rewrite the code and things, and you can connect to, or you can communicate to the other applications which are written in a different native languages. This is ActiveMQ is one of the service, the open source, basically the service which helps you to talk with the different different protocols, the open protocols, as I mentioned, like AMQP, MQTT, which is to manage your IoT devices, STOMP for WebSockets, the JMS messaging interface, and the other different platforms. So when you have like the work with related to these kind of platforms, then you have to migrate the application to cloud, and you have to communicate it with different systems. Then you use this particular service. Okay. Now let's go here and let's see if we got Amazon MQ. There's still creation in process. Let's see what we get from here. So here, like it will tell me the broker status, whatever the instance type I'm using, the single instance broker, where then I will get one endpoint also through which basically I have to connect. So right now I didn't got any endpoint here. So we have to do this. It takes time. Meanwhile, let me fix one more thing. Ashutosh is in the class. No. When I teach about development, you are not there. Okay. Okay. So this we will use in the next one. Okay, we'll come back to this one, but so this service, like mostly, see, when we talk about the different open protocols and these things, and to migrate those kind of applications which are working on a different protocols, these open protocols to cloud, you use this active MQ service, because MQ actually uses Apache Active MQ, which is one of the open source service provided by Apache, which allows you to connect to the different, like for any other protocols and these things, connect you to the different languages which are written in any other native language. Okay, I have not seen any such question, I think, like from the in the exam. Prasad, have you seen any question related to this? Prasad? Okay, so no problem. So I have not, but if you see any questions, so they will be talking about Apache Active MQ service, or they will be talking about any of these protocols or these things. Okay. Now let's move to the Amazon API gateway. Meanwhile, that is being configured. So Amazon API gateway basically is the service which allows, which is mostly useful for the developers. Okay, it's mostly like used by developers to create the APIs and the then utilize the resources and things in the AWS. From a solution architect point of view, we have to know some few things. So let's understand before that what is API. Does anyone aware about it? What is API?
Yeah, it's kind of common functionality we expose as a part of API to the outside world.
Okay. Anyone else want to like define it?
Uh, it
Yeah, some
acts as an
already,
interface. Yeah.
yeah, so, yeah, some
Yeah.
already developed piece of code available to be used.
Okay, that's like more approachable one. Yeah, so I think it was like whoever it was. So the next Nisha Balu, we can try.
Yeah. So I think it's kind of an interface uh, between multiple softwares or something application.
Okay, we can say that also. Saurabh, you want to put anything or add anything?
No, Sachin. So I think it's mostly the application programming interface to have a set of functionality being put into it, which can be reused by multiple systems or
Okay.
users.
We can also say it's a kind of a library available.
Yes, we can. So fine. So now we see that suppose, let's see here that what actually are trying to convey with this two diagrams in the slide, that you have created some application in C++. Okay. Now if some other particular uh, person who has written some application in any other language, and he or she wants to talk to your code or use your code or use your functionality, he cannot do that. He cannot communicate that directly. Okay, because there should be some mechanism, something should be set up. So they so like it came up with one feature known as API, which is known as application programming interface. So what you do, that you create your code or you create your library as a API, so that it could be reusable, as well as it can be used by any other programming languages also as a library. Mean they can import it as a library and they can use those methods. Okay, so when you can use it in any of the things. So similarly, Amazon also provides you, it's the facility where you can create the API, you can create the APIs and all those things, and then you can interact with the uh, with help of that API, you can utilize that in other to use other services. Okay, so AWS has the two kinds of APIs, where like not only AWS, mostly we have two kinds of APIs, like where you would see that REST API and SOAP. So SOAP is also, both of them work on HTTP only, but in SOAP you have additional SOAP protocol. Okay, so we have REST and SOAP, but mostly these days we use REST APIs only. SOAP is like, I don't see too much usage of that. So AWS gives you that this facility where you can create, maintain, and publish or monitor your own APIs. Okay, either the REST or the SOAP or the WebSocket APIs and these things. Okay, we all works on HTTP protocol or HTTPS protocols only, and where you can, with help of this API, you can handle like lot of tasks. You can like authorizations, access controls, the monitoring, the version management, connecting with the different other services, or calling the Lambda functions, and like calling the from the Lambda functions and these things. Okay, and like this API gateway helps you to create to build up a serverless applications. Okay, like it is very important when you have to build a serverless application. API gateway plays a major role. Okay, and it provides you one endpoint where it gives you API ID dot execute hyphen API, the region name, and these things. Okay, so we have a different types of endpoints. Okay, one is the edge optimized endpoints, one is the regional endpoint, and one is the private endpoint. Now, regional endpoint means that that will be specific to that particular region. Edge optimized endpoint will be like like that particular endpoint will be will be accessed via the nearest endpoint from the API gateway cache and these things. And private means will be like just limited to the particular people to whom it has been authorized, or if not, just to you. Mainly used by developers. From the architect point of view, we should know that, okay, if serverless kind of application is building up, okay, or if we have to build up some REST, where we have to build up some REST API and talk to Lambda or other services, we can go ahead with this option. Okay, and we have a three different type of endpoints known as the regional endpoint, the private endpoints, and the um, edge optimized endpoints. Okay. Now, what earlier was used to happen, that you have built up the application. Now there is a firewall, and you create the API. You have built up an application, let's say in the Java, which is has some its own database. And if other people have to communicate, so you have to like bypass this firewall and then talk to API so that you can talk to this application server. So means this is your blockage here. This API and firewall is the blockage, because it is protecting your, basically API is what it is doing. Like somehow like that code is, if it is not accessible or you are not given access to any other person, so he or she will not able to access and utilize it in their code. So this logic API and firewall has been replaced by the Amazon API gateway by Amazon, and they use this API gateway to with other services like AWS services like Lambda or EC2, DynamoDB, or any other things, or they can use with VPC also, or with on-premises data center also, to connect with these services. They they create the API gateway. They can create the API gateway and send out the logs and these things to CloudWatch logs or to the API gateway cache. We have a demonstration for this. Okay, where we'll see that how actually it works. Before that, let's see if this is, wow, it is, broker status is running. So okay, so you see that now here I got the active MQ web console. Okay, so sorry guys, I'm just going here and there a little bit, but like let's complete this first of all. And we have a different endpoints for all the open protocols which we talked about. Let's hit this URL. Okay, it's loading completely. It is not accessible only. The reason it is not accessible, because I think there is a security group issue. It is working on 8162 port. I have to open the 8162 port. Yep, it timed
Sachin, in the meantime, I just wanted to check with you. This Amazon MQ and SQS. These two, Amazon MQ
Hmm.
and SQS. So
Hmm.
in certification, how primarily we should go for which option, like whether it should be Amazon MQ.
MQ will talk about open protocols always.
Okay. So in case if any question talks about sending a notification to the target system or some system.
And yeah, sending a notification, and combinedly it is talking about open protocol or any of these protocol or Apache active this service, then you will go ahead with MQ only, because when you configure MQ like further levels, okay, so you can use it, actually. So when you see this configurations, this broker configuration and edit configurations, not this one. So basically it allows you to configure with this thing, SNS or SQS. It gives you the, like, it gives you those options also. So it supports SNS, SQS both, but if in exam you will see that if they are talking about open protocols and configuring it with SNS, SQS, then also you will go with active MQ only.
And there is also one question, Saurabh. So if they ask about that company is having already a broker and MQ at their own device and want to migrate it to AWS, what is the easiest option? So in that case also Amazon MQ is the preferred choice rather than SQS.
Okay. Got it. Yeah.
Okay, so I have opened this. It is asking me for password. I'm not very sure what password I put. Let it take its time. Meanwhile, let's move to API Gateway and complete that first. So API Gateway is useful to manage the APIs, and you can build and deploy the APIs. Let's see the entire process, that how we do all these things in API Gateway. Okay. Now here, once you come up to this console, it gives you the option that you want to create a HTTP API or the WebSocket API, different types of API, REST private API, REST API, and these things. So you can create whatever the API you want to do, and if you already have some APIs, you can go ahead and you can import it. However, let's build one API, the REST API. Now, to build the API, we would need few more things. Okay, so we have to build a REST API. Okay, it gives you one example API, that how you can, like, there's some Swagger API. I don't know what is it, but let's create our own API, new API. Let's give it the name as my first API. You can, as I said, that there are three endpoint types. So let's put the edge optimized one. Create API.
What is the difference between these endpoint types?
So if you want to restrict your API to particular Northern Virginia region, you will go ahead with Northern Regional API. If you want to restrict your API only to you, okay, that is a private, you want to create a private one, then you will go ahead private one, and or for a specific users. Or if you like the normal, the edge optimized will, like, it's work based on that edge locations only. the nearest location it will select when you hit that API.
Sorry, what is edge optimized?
Like in CloudFront, we have edge locations, like the CloudFront edge locations, which will take the, when you hit the API, so it will take the nearest edge location from the cache and these things. So similarly, it will it works similarly. Okay, now here this is the resource which is created here. Okay, let's say this resource name is root resource. Let me create one method here, and these are the HTTP methods only. You can't include like your, if you have any other custom, you can do that, but that way. So you have to, you can integrate that get method with the Lambda function HTTP or whatever method it is. Let me integrate with the Lambda function. For that, I have to create the Lambda function first. Let me create the Lambda function. We'll talk about Lambda different way, like completely different. Let's say that my first function. I'm building with Python, so Python choose create a new role for the execution, create function. This is the function which is there. Let me put up my function. I have written nothing. I have written kind of same function where in Python I have defined the Lambda handle body, and so I'm using the default one, but just I'm putting up JSON.dumps, which will basically do nothing. Just put it in a JSON like the format, and headers I'm using as a content type as application JSON. For more better understanding this way. So I've created this. I will save this. Let me test it out. Hello world. New. Missing on module lambda underscore function. Status C capital S capital. Okay, fine. That's just important thing is to remember our function name. That is my first function. Let's call it via this and see if it is working. So we have to use the Lambda proxy integration so that we can connect to the Lambda, and we'll choose the Lambda region as this. Let's say that my first function. Okay, and let it be use default timeout and save. It says that you are about to give the permission, so it will basically create a permission to invoke the Lambda function. So once you click on OK, it will come like that. Okay, now you see that it is like this method request is going and the integration request is going, and like anyways we are not sending any, like whatever the response is coming, that will go back to client. Let's test it out. So make a test parameter test. So it's message internal server error. Okay. Let me do one more thing. However, there is no issue with my function, that I'm pretty sure. Like with my code, there is no issue.
ये हो गया असली डेवलपर। टेस्टर को बोलते हैं मेरे कोड में तो हो ही नहीं सकता प्रॉब्लम।
होता भी नहीं है।
अरे गलती टेस्टर की होती है हमेशा, गलत टेस्ट केस चूज करते हैं।
सही बात है। अब तो वैसे भी डेवऑप्स मॉडल पे काम करते हैं,
अरे,
टेस्टिंग भी खुद ही करते हैं, तो इशू ऐसे नहीं आते हैं। Yes, David. I think I'm using a wrong configure.
ये टेस्ट इवेंट हेलो वर्ल्ड उसने खुद बना के दिया है क्या?
हाँ, syntax error in module lambda function. कहाँ दिख रही है इसको syntax? सही तो है पूरा कोड। Okay, yes. So now you guys see that in response we are getting this in a JSON which we have configured. It's status code 200, and I'm printing the body like in the JSON.dumps. So hello from lambda, it will give this, and header will be content type this, and I'm getting like this is what we are getting in the lambda function. So this is a very small example of a lambda function. Like as I'm like good with Python, so I've written with in Python this code where I've defined one function and I've given two parameters, event and context. So basically these are the two parameters for the lambda handler function where I will be printing event also to see that what all things are coming in the API response. So that's the reason I'm using that. And context I've given to define the header type, that is the context type and all those things to define the headers and all. I'm using these things. And I'm just doing nothing. I'm just saying that this function runs successfully. So I've written a JSON which should return a status code as 200, body as this, but this. But so how many people have worked with API here? The definition every one of us know, but anyone has worked on APIs and all? I think Nisha Apollo, someone is there. Okay. Can you tell me, like, if I execute with API, what kind of what format I should get output? What should I get in the output in the API response?
It should be web page something with the message hello from Lambda.
No, I'm not hitting any endpoint here, so that will not be the case. But yeah, second part is correct. So that is that you will get only the body part in the API response. The header part will be in the header format and those things. Let's see here. So we were testing this. Let's test it out again. Okay, lambda, my first function. This is all is there. Test it. Internal server error, why? One second, guys. Let me go to APIs. Either it could not invoke the lambda this. It will go to my first API, and before resources and these things, there is it should create one role actually. So we have set authorization is none. Now this should not be the case, because if my lambda function is working here, I should get the output definitely. Let me just do one thing. Let me reconfigure one API. There is definitely some issue uh, with the rules or something. API, create the API. Now new API. Now in this, I'll create a method under this resource. I'll create the get method. This method has been configured. Integration type lambda function. Lambda region is US East 1. Lambda function is my first function. Is default or not. Just save. About to give this function is this. That's fine. Okay. So endpoint request URL this. Invocation endpoint request URL XAMG this. Authorization is null. XAMG date accept application JSON. This is malformed lambda proxy response. So somewhere it is facing you see that endpoint response before body transformation, it is picking up those things from lambda. However, just somewhere it is facing issue with the authorization error. I'll see that why it is facing that error. But sorry. So it has not done not done much things. It has just included is base 64 as this. Let's do one more thing. Let's remove this also for now. Just save it and test it out. So I got the same response. And now let me test it out again. Yep. What the hell? Then why this headers were causing the issue? Content type array. Yeah. This is how I have to configure the content type. That was the issue. I'm pretty sure. Just a minute, guys. We'll fix it. This is how it has to be configured. So now you see before that you see here that we are getting this, okay, and the response header, it is not giving me content type of these things, it's giving me some trace ID there. Okay, what you can do, let's create one more resource, okay, and let's give it the name as test. So this is the resource path. Let's say create get resource. So I'll get one more resource. Now under this resource, if I create one more method, so get method I have created, and again I'm using these same configurations, like my first my second function, okay, Okay, it will give me right now error. So for now, I'm just disabling this. We'll test that, and so I'll quickly go and I'll create the second function. My second function. I'll use the environment as Python 3.8 only. Create function. And so this is the function. Here I will use that hello from second resource, and apart from that I will use print event so that it should print event to me. Save. So it is working, no errors are there, all good right now. So here I'll use my second event function. Save. It says okay. Okay, the same thing is done. I'll create test. So hello from second resource I got, and you see here that it has printed the entire thus event, that what is the response is from /test which I have created. HTTP method get query string parameters. Okay, my stages variable request contact, lot of information whatever we are getting from the API response. Now our task is to deploy this API, because we have created the API, we have created one this with get and this thing. So we have formed the methods and things. Now my task is to deploy the API. So let's say I'll go to deploy stage. I'll say dev and nothing much. I'll create deploy. Now as soon as I have done deploy, so I should get the endpoint. All these things are correct. Save changes. Yeah, this is my invoke URL. This is my invoke URL for API. Let me open this. So at root user, I should getting hello from Lambda. I'm getting that. And at test user, I should get hello from second resource. I'm getting hello from second resource. So this is how you can create the API. This was a very basic example where you can hit after creating the APIs and with the help of AWS, you can build everything, whatever the logic and these things, kind of serverless applications and all, using the Lambda and the other import APIs also you want to use, you can use and perform the actions, whatever you want to do. I hope this is clear for everyone. Any questions, anything here? Okay. So let's come to this one, if it is done or not. Yes. My goodness. Okay, it is doing this. Broker is pending modifications. Password 123456. Yes. Basically, the service MQ, what I wanted to show you guys, that this is my opens my ActiveMQ, and from here I can manage the ActiveMQ broker. So now, as we saw that we are sending the messages and configuring and doing those things from the S3 in the SQS. Similarly, we can do these things from here also. Okay, I'm not sure that why it is taking so much of time to load, because you see that it's still in the pending modification stage. So if that got finished, so we can able to hit it. But it actually performs the same way where you can send a message and receive the message. Okay, so this was all about the API gateway and these things. So guys, any questions till now? Are you there? Okay, fine. So today we talked about mainly the SQS service, and then we talked about the kinesis. Kinesis, I will be sharing the document as well to you guys. And we talked about the MQ, that where we create the broker and message broker basically. And then we talked about the this thing API gateway, and we saw that how we can create the Lambda function and how you can create the APIs with the help of a Lambda functions. You can invoke those things. So this is what we discussed. This is all we discussed today. And so now, so this covers up our like few more topics for our session today. We'll cover up other things like Route 53 and the CloudFront and these things also. And so any doubts, any questions, let me know. Already most of the practice tests and things have been shared with you guys. So if there is any other practice, if there is one more practice test which I will be sharing with you guys. And there are a few more things which we will be looking into parallelly, the separate module test also. So if everybody is fine, can we have a quick test? Like quick test means that not on the deep topics like on like yesterday, but a particular module wise test for something. If everybody is fine.
Sure.
Okay. We still have time. We can go ahead with that. Let me just open the something. Okay, so I'll be sharing my screen back. Just a minute. Okay, so I hope everyone can see my screen. So let's practice directly from here. It hardly matters. Okay, so let's, if this is the, these are the 10 questions on RDS and DynamoDB, as the rules are same. So Prasad and Saurabh would be the last people to answer, and first answers would be expected from the rest of the 3 people. So yes, so it says that you are working as a cloud architect in a big IT firm to ensure high availability of both web servers and the database of your web application. You deployed your auto-scaled EC2 instances in multiple availability zone with an application load balancers. These things.